Just a video overview taking you through the example in activity recognizing models. All right, so the first thing that we're going to do is create a graph for this data set. All right, so I'm going to grab a scatter plot, insert chart, drop down, oops, overshot it, grab the scatter chart. I'm going to resize it and move it over. Now, based off of the instructions, I need to make a determination of what type of model would be most reasonable between among these choices. So I'm noticing a downward tilt followed by an upward. So if I look at my different possibilities in the intro tab, I have exponential, degree 2 polynomial, log, degree 3 polynomial. The only one I could kind of make a case for would be the degree 2 polynomial. All right, so I'm going to go in here, edit my chart, customize, go to series. I'm going to select trend line. I'm going to go to polynomial and make sure it says degree 2. I'm going to have it show the r squared value, and I'll ask it to show the equation also. All right. So here I'm saying degree 2 polynomial. The coefficient of determination is your r squared value, so that's 0.494. Not really a strong relationship between the two variables, so we'll just kind of leave it at that. The equation of the best fit model, humidity equals all of this stuff. So I'll write it, instead of using x's and y's, I'm going to use particular values. So hum for humidity, you can abbreviate it in any way that makes sense. 146 minus 4.69 times the high temperature, which is the x, but we want the particular, plus 0.0502 times the high temperature squared. All right, and it says if the trend continues, what would be the humidity if the temperature was 32 degrees Fahrenheit. So I would use this formula basically. I mean, if you want, you just copy paste everything equals on, put it in, and then just put the whatever the high temperature was, in this case 32. All right. You got to make sure if you're ever multiplying that you use a multiplication symbol. Excel doesn't understand it in the algebraic notation of number parentheses, so get those multiplications in there. And of course I get an error, so where did I go wrong? There we go. I used a different kind of equals minus sign, so that's the you just want to use a regular dash. I used a hyphen. So we want to know, is it reasonable? So a couple of ways. You could say yes, it seems consistent with the trend of the data. You could also go to this website that I indicated here. I'm going to just grab a website. I'll open a browser. So this is where I collected the information to begin with. 32 degrees is a winter temperature typically, so I'm gonna grab something from maybe January and see if I could find a high temperature of 32. I scroll along, high temperature 32, high temperature 32. All right, with that high temperature of 32, we come up with a humidity value of 49. Okay, so it's consistent with the trend of the data. 49 isn't too far from 47. Historical value from website is close to what we predicted, or what was predicted, however you want to write that. I'll get this in yellow. Now we want predicted humidities based off of these values. So what I can do is I can take the formula that I used here, put it in here. Instead of 32, I'm going to put in cell B27 here and here. Lock it in, accept it. So these are what my model predicts should have been the temperature. If I take the residual, or find the residuals by subtracting the actual value minus the predicted value, and I'll get how far off my prediction was. So I'm going to do equals. I'm going to take my first value here and subtract from it my first value here, lock it in, accept it. So this one was way off. Oh, a little label issue here. Hold on. Boop. There we go. This one is way off. This is pretty close. Way off. Way off. A lot of way off. All right. So what I want to do is construct a scatter plot to get an idea of whether or not this quadratic model, the degree 2 polynomial model, is correct. And we do this the same way we did the scatter plot before, except it's high temp versus residuals. So insert, chart, grab, oh, I already have scatter chart, and it looks good. All right, so the only other thing that remains here is making a determination of whether or not that quadratic model is appropriate. All right, so if it looks like the points are just kind of scattered all over the place, no real pattern to it, then we would say that the model we selected is appropriate. All right, I don't see a pattern here, so I would say no. And I actually wrote the conclusion for you. All right, so if you put a value in here, whatever you put in this drop down, whatever you put in that drop down, gets put into your conclusion. All right, so if I said yes, the degree 2 polynomial model is likely appropriate. If I said no, it's not appropriate. So I don't see a pattern, right? So that's a typo. I don't see a pattern, so the degree 2 polynomial is likely appropriate. All right, that's the correct one, and I'll update that. But if I said yes, it would say it's likely not appropriate, so it's the opposite relationship. All right, so now you should be able to move on to the analysis for bouncing balls 1, 2, and 3.